Friends, in this video I am talking about why is electric heater used. In this art video, we will explain the benefit of the electrical heater and where it used, basic calculation, thermal imaging, and electrical with gas boilers, energy efficiency, and much more. Okay, so let's get started. So let's see the video. Friends, this cable generation heat when we pass and the electrical current through it, and I am going to show you how it works. With electricity emerging as the source of the renewable energy, it's the enable electric heating as the such as a sustainable choice for the future. See the specification for their entire range using the link in the video description. Do all out of the link down below. Okay, so let's get started and see. First is how it's work. So let's get started. All electrical cable generation some heat. Electrical components also generate heat. That how the electricity energy leaves the circuit and the cause of the hour energy meter to measure the energy consumption. Okay, so let's see the generally this heat is the wasted energy. We do not want this in our circuits or in our electrical distribution system, and we often need the additional cooling to remove this unwanted heat from our devices. Okay, otherwise they will break. However, it's the sometimes very useful. For the example, in the underfloor heating where the wire generation heat to warm our home, we can easily turn it on and off, and the heat is the distribution throughout the room, not just along one will like a radiator. Okay, when we pass the electrical current through a circuit, the electrons will the collided with the atoms in the wire and the electronic components, and these collisions convert the kinetic energy into the heat. Okay, some wires like the standard copper one generate a small amounts of heat, but this nichrome wire produce a lot of the heat. This is the allow, meaning the mixture of the materials especially designed to the produce the very high temperature. It gets so hot it even goes. That's also how old incandescent light work. The material gets so hot in the glows and the lamps produce a lot of heat. Okay, the heat generation depends on the resistance of the material used as well as the amount of the current pass through the wire, and also the amount of the time current is allowed to the pass through the wire. Okay, next is some material have the high resistance and the some at the low resistance. Okay, this is basically just as a measurements of the how easy an electrons can pass through it without the cooling. Okay, high resistance means the lot of the collisions and so the lot of the heat generated. Okay, this the thickness and the length of the wire affects the resistance. Short sticks wire have less resistance than the longer thin wire. That wide distributed cable are the thick. Okay, to reduce the resistance and the reduce the energy loss. Okay, for example, this heating mats covers 1 square meter and the contains around the 13 meters of cable. The cable a resistance of 246 ohms. If we connect this to 230 volt supply, the current demand will be the roughly 0.935 ampere. The power demands in therefore 215 watts or the 0.2215 kilowatts. Okay, so if we run it for 5 hours, it will produce 1.07 kWh of heat, and we will pay for 1.07 kilowatt hour of electricity. When electrical heating used and why? So let's get started. Where is electrical heater used and why? Electrical heater in the use of everywhere from the kettles, toaster, hair dryer, electrical shower, fan, heater, underfloor heating, frost protection, and so many other applications. Okay, the reason electrical heater is the popular is that is the very quick and easy to install compared to a steam or the hot water system. Okay, there's no risk of the leakage and water damage. We can easily shape it to fit our applications. It's almost 100% energy efficient, and when powered by the renewable energy source, it has the almost zero carbon emission. Okay, next is, so how are they used? So let's get started and see. Well, we saw earlier that we can use this nichrome wire to generate heat. That's the exactly what we find the inside a toaster. Just some exposed wire that the surround the slice of the bread, and the heat of the wire and the enough to toast the bread. After a short duration, the power is cut and the heat stops nearby the instantly, but the heat does not travel too far. We really need it close and the bread for this to work. Okay, so instead we can couple this wheel at the fan, and this allow us to force air over the heating elements. As the air passes over the heating elements, it will pick this heat, and so we can project the heat into the room. The heat travels much faster with these methods. Okay, now the problem with this design it is that if everything physically touch across the heating elements or the between the heating elements and the ground, we get a short circuit which will trip the breaker or even the damage the devices. Okay, next is, but we can enclose the heating elements link in this kettle where the element is the submerged in water. With these devices, that wire is the raffle into the coil and the surrounded by the power, typically magnesium oxide, and the enclosed with the stainless steel case. Now, when the wire and the heated, the heat transferred out thought the magnesium oxide thought the tube wall and into the water, which prevents their water from the creating the short circuit. Okay, with the all these methods, the heating elements has a small surface areas, so a transfer sufficient thermal energy we need of the heating element to reach very high temperature. However, with the underfloor electrical heating, that the surface area is very large and it's cover most of the room, so the surface temperature is the much lower and the heat is the distributed evenly across the entire room. Okay, next is ordinary we might find the force air heating vents or the single radiator on one of the walls, which is the either the electric hot water of the steam heater. This will be the high temperature as it has the relatively small surface areas minus लगभग only 60 degrees. Hot air rises to the leads to the poor thermal distribution and the thermal comfort in the compression to underfloor the heating. We can either have to the total underfloor heating or the we can combines this with the additional heat source from those extremely cold winter days. Okay, if you look at the simple bathroom installation, the system is the relatively simple. We just have to heating cable installed across the floor. This is the connected to the wall mounted thermostat. We also have a temperature sensor connected from the thermostat and the running down on the floor also. This is them all covered in the adhesive and the tilt overs. Okay, The thermostat is the connected to the main power supply. When is detected the floor temperature is lower than desired temperature. Okay, it allows the electricity to flow through the wire, which heats the floor up. Okay, so the cable just have the two heating elements inside. This might be the solid core wire or the multiple extender. This will be the covered in the insulation and with either thin metal protective screening and then the coated with either PVC cutter layer. Okay, we also find the electric heating cables used for frost protection, typically along and the extremely pipe which has the risk of the freezing. The cable is installed along the pipe and the fitting and is usually then the insulated temperature sensor and thermostat will then the monitor the pipes and the ensure the fluid within the pipe styles above the freezing point, as this will the otherwise damage the pipes. Okay, so additionally we can use the heating cable to ensure the fluid in the pipe remains at a certain temperature as it travel between the various production points. For example, food productions of the pharmaceuticals. Even if the pipes were the insulated, some heats will the escape and the over the long distance. This called the cool the product too much. So electricity heating ensure it always the correct temperature. Okay. Thanks for watching this video. Thank you.